Hello. Hello, Nishant.
I think Dr. Koral is with us. So let me first give a brief introduction about Dr. Koral. So first of all, let me welcome all the members who are participating in today's webinar. So as a sectional committee, we are always encouraging our members to showcase their talents, experience, and we are always giving opportunities for them to express themselves in front of our membership. So this is one of the example. Dr. Koral voluntarily request us to give an opportunity to present his innovations, his research works, and his experience to our membership, and he's expecting further support from our membership. So as a sectional committee, we gave an opportunity to him. So he will be discussing his experience and knowledge in telecommunication industry and the things that he has engaged in terms of projects and other works. So let me first give a brief introduction to Dr. Korale, science in telecommunication and data science. He holds a PhD from Imperial College London and master's degree from Columbia University, and he holds an MBA from University of Srirathanapura. He transferred to research and engineering role in UK, working at Motorola and NEC Siemens. He held leadership positions at AMBA Research, Dialog Asiata, London Stock Exchange, Colombo branch, and campus. So Dr. Koral is a member of IESL, IET, and IEEE. So without taking much time, I would like to give this opportunity to Engineer Dr. Koral to discuss his experience and his.
So thank you, Mr. Vanyarachi, in the committee. Yes, I see you for giving me the chance to come in this presentation. Actually, I wanted to ask you in the for his help, advice about how to do some research work I have been doing for many years, ISL and IET. So every year at ISL and IET, I present a paper in the annual conference in August, October. IET is also here. And I work with the engineers at Dialog mainly, and then from Millennium IT.
And a noisy environment. So I'm sure you are getting ready for the presentation.
Can you hear me now? Hello? Hello, can you hear me now?
Yes, now you are clear.
Great, thank you very much. So did you get my first part of the what I said?
I think you can start.
Okay, right. Thank you very much. Yeah, thank you, Mr. Vannaji. Thank you very much for the section and the committee. Electrical engineering, telecommunication, committee members, and the ES, the CEO, and the ISL members for coming to this presentation. It's a very special thing to US membership for the ISF. I wasn't hoping for that. Actually, I wanted to ask the CEO his advice about some research work I've been doing in the last 10, 15 years from Dialog to MIT. As engineers are also in the management. It's about the research work R&D, telecommunication. I have been publishing those papers at the ISL and IET conferences in August and October every year for about the last 15 years. So I met the ES, the CEO, and asked him, there are some innovations, especially one paper, or maybe one or two papers. How can I put this to the standards, the telecom industry? So I have worked at Motorola before. It was many years ago, in 2005. For about 4 years I was there. So in those big companies, there are engineers and senior people representing the company in the standards, in the industry forum. So they can suggest patterns and innovations and is useful to the company, and then they can get into the standard and work with the other companies in the industry. Those are done by big companies. And they can,
Dr. Korala, excuse me, if you can little bit louder, if you can close to the microphone of the
right.
device, the
Yes. Yes.
audience will be more clear.
Right.
Thank you.
So that's the idea. So I was hoping to get some help from the ISL management, CEOs and the committees about how I can do this. So I approached him and I asked him for a meeting. And then he suggested that we do this presentation. And Mr. Vanyarek says, we set this up. I'm grateful to you all for coming to listen to this. I want your help and ideas because I have done this work for many, many years. And these are practical things done at Dialogue in MIT. Projects, different divisions, managers. I work with engineers there. These are all innovations, products, prototypes, our own software, working things done to help Dialogue in its business, serve the customers, invent new services, make intellectual property, and also to work with our group companies, like the Science Forum, to collaborate with them, to tell them what we are doing in Colombo, and then we go to a meeting with them also. So like that, I wanted to ask your help now, and that is what the ES suggested I do. So this email is about that. I want to submit a proposal to the telecom industry and standard bodies about 1 or 2 papers I have presented at the ISF and the IET. In this presentation, I'll just introduce one paper. There are about 10-15 papers that we have done at Dialogue.
Dr. Korala, excuse me, little feedback from the audience.
Yes.
So they are telling that the voice is not clear and audible. So I'm also experiencing the same here.
Okay.
So can you just
Yes.
focus on the microphone of the device so that
Yes,
the audience
yes.
will have a more clear idea?
Right. So this is today's presentation is one paper, about 10 or 15 papers done over the last 10-15 years. So what I send this email as an agenda for today's meeting. So ask the members for their support to submit a proposal, telecommunication industry, standards bodies to consider innovations in telecommunications, engineering, and customer technology. I have presented this at the ISM and IET. The papers are published in our transactions. You can refer them, and there are the university also can get involved because they have been reviewed by the local campuses and academics. And their projects I have done at Dialogue and Millennium IT. I want to suggest that we try to get some IP and patents on the work that has been done. But I'll use one paper to illustrate this and then ask for your help to come up with ideas that you can use these innovations to make your own, invent new services, invent new software. So these are some models and prototypes which the members or the engineers can use to develop their own solutions to problems, their own problems in their work. So this third point is about the algorithms and models, IP and prototypes implemented in software. So these are engineering models and the software has been developed to implement them, and we get some outputs, we get results, we can prove that it's working. And this is an example that other companies or other engineers can use to develop their own ideas and solutions. Because what I have done is also by looking at other research, theses and papers, other models that are there in industry. But these are also new, not found anywhere else, as far as I know. So that's the idea. Yeah, so then the second part of the email is, these are all to do with e-commerce and customer data, data science, things that you can use in other industries also. So in Sri Lanka, we have a lot of finance and banking, and that is a new area that even telecom companies are going to work in. So these could be things that we have done many years ago, 10 years ago, sometimes 5 years ago, which are ahead of what was there at that time. And even now, I think it could be useful for companies and engineers to look at this and come up with their own ideas. So my objective is to use this presentation today to ask your help to look at what I have done and the engineers and what has been done at Dialogue and MIT. I'll use one paper only. We don't have time to go over all the things we have done. And to use this paper in the kinds of things that are done at big companies like Motorola, where they have people selected to work with other companies, industry standards. They are doing and representing the company in meetings. And they have opportunity to suggest things. So it's difficult for one person to do this, but ISL or TRC, somebody from a big organization can do that. That's why I went to the ES to ask him how we might do this. So this is the presentation that's coming from that. So I were to introduce this one. So there is a paper here. Presentation is going to present one paper, but then there are many things involved in using the idea or the innovations in that paper, how we might be able to put it into the standards or to the industry, how we can tell those companies what we have done. Can we get some patents? Can we get a project with them? Get their feedback and ideas. So that's what I'm trying to do here. So the paper, this particular paper, is from 2019. I did this work at Millennium IT for the London stock market. It's about a certain number of events and the time over which to observe them. So we'll come to the paper in a minute. But the job there was, the assignment was a problem of market surveillance, where people can manipulate the market by trading in ways that are manipulative. So one way to do that, or to find that, is to find outliers in trading. So in trading, this could be one way of finding outliers by looking at how many trades happen in a particular time interval, and what is normal and what is an outlier. So this model was for that. This can also be used for telecommunication, in queuing, lots of logistics, many applications you can do with this. That's why I selected this for you all to look at. And the paper is published in the ISL Transactions. This paper 92. That is the reference. I'll show the paper a little bit later. So what I'm saying is, I'm going to use this paper, one paper of about 10, 15 papers I published here. And the engineers like Dialog have contributed, and Millennium Mighty also. See if we can use this to get some kind of patent IP with the telecommunication industry or other industries, maybe the stock market. These are new things as far as I know, and they are working prototypes, and you can use this to develop other things. Somebody can use this model in another system. They can develop a software, new services. Maybe you can develop standards. So to do that, we need your help and support. The ISL has to, or a big company organization has to suggest this to the other companies and standards bodies. So there are
Dr. Corali, if you can
Yes.
put this into the presentation mode, that will be convenient for our listeners. And if you can little bit increase your voice, that will be also helpful, because this will be a live recording. So
Yes.
audience can later refer this video. So thank you. Please continue.
Okay, thank you. So that's the objective. And then what we can do with this. So when you have an innovation, especially this particular one I'm going to introduce and present in the paper. So new things can be done using those innovations. So if we get a patent or if we get a standard, then we can get royalties, or we can get some kind of new products. We can work with other companies and develop new things. So these are in telecommunication, in data science, statistical learning, then in the stock market, logistics, many places you can use this. So to do this, what this is about, it's an engineering model. I'll show this later. Just want to introduce this. And I hope to stop in about 1 hour. I won't take 2 hours. It's an engineering model. And that problem was detect outliers in trading. And one thing we look for in the stock market manipulations, we have to find outliers. The outliers in trading is when there are an unusual number of trading events. So we want to find what is a normal number of trading events and what is a something outlier. So this is a way of detecting that. It is also a way of looking at load on a queuing system, a software system, a message passing system. The paper is about that one. Where we can apply this to a queuing system and look at the number of messages in a system. So we end up by doing this, to do this, we have an engineering model, we have an algorithm, some steps, how to do the engineering model. The engineering model is about putting some input. We put in the number of the trading events. People are buying and selling. We will give them the kinds of trades, the time at which it happens. And that will be an input to our model. So the model will take that and process that. It will look at how many trading events happen in a particular time interval. We can model that in so many ways. We have those engineering statistics to find that. And it will output an outlier or some statistics which we can use to compare what is normal behavior and what is not normal. So this is also what is called statistical learning methods, data science. So because of this wide range of things involved, there are a lot of places where people can use this to innovate, to invent, maybe put this idea in another software or put this idea in another model. So somebody might see this and update their software or their engineering model using these ideas. So I have been doing that at Dialogue also, using research and other people's thesis. We get ideas about what we can do by looking at the research done at universities and research papers. Sometimes we can look at the software. We will see if if these things are already done or what is there in the software. So by looking at the software itself, and that Excel software, SAS software, there are lots of statistical learning software. They are used for different software, used for different engineers are using MATLAB. Those are used by data scientists, IT people, statisticians. So they can decide whether this is a useful thing, whether they can put that in their software or use Excel to implement this, update the Excel model and put this idea in there. So it's also about computer programming. Computer programming is model and is implemented as a computer program, a MATLAB computer program. So somebody having a computer program might say this and say, I can this idea. It might be something useful to them. Or they might tell us there's a better way of doing this. They've already done this. There are lots of benefits by looking at it in this way. Other one is the commercial software, application software development. We might develop a special software to do a particular specific thing, like the market surveillance or QE model. You want to look at load in a telephone system. We might use this idea, develop a new software for network planning, call centers. So people in the industry doing this kind of work, and there will be lots more things. These are 5 things which are there in this model. Engineering model, we input the data, process the data, produce an output. This model is, in this case, to look for outliers in trading. That was our objective. But we can use a similar idea, that same engineering model. We look for outliers in the number of events, trading events. We might adapt that to look at load in a queuing system. How many messages are coming? How long are we taking to send the message? Or if you're in a supermarket, we have so many servers, counters, so many customers are coming, and at what rate are they leaving? How much delay? How much cost is involved? So it's like a telephone system, like the telephone exchanges and packet switching. So those things are applicable. They might be able to use this in one of those already existing models. They might be able to update what they are doing. And they can tell us their ideas about what they have been doing. But in this presentation, the objective is to get some IP patterns to inform the companies, get some talk to the standards organizations, see if they can consider what we have done. So these are also a result of business. The company, the Millennium IT company, is working for the London Stock Exchange. It's actually part of that. LSE bought the company, and I was working there. So the company has an initiative to develop a prototype for the market surveillance. In Dialogue, the top management has various initiatives to develop the organization. Different general managers need different kinds of software, business models, data science models, for them to get additional information about how things are going. They can trial a new model, contact customers, recommend products, measure sentiment. So those are the kinds of things we have been doing. At Dialogue also, usually for a general manager, with top management oversight and their initiatives. I have developed these models with the engineers there and presented it at ISN IUT. So this is only one of those. We don't have time to look at all of those. I have put the list in the presentation. You can look at those also, but those are also to do with telecommunication. But later on, they might be useful in other industries, in financial technology, in e-commerce. So these are data science models or custom technology. There will profile customers, their use of services. How do we position the dialogue service with respect to Mobitel? Or can we tell that to the Asiatic company? What we have done here, can we give a model to them? They can take it and adapt it. So we were doing new things like that, which were not done elsewhere. I'm not sure whether they were done in other telcos. I think many of these may not have been done. There are some use cases now being developed, and I'll show you that also. So this may be something new for the telecommunication industry because these are coming from other areas, and those companies are better at them. But then we are also doing things in the local market, specific problems. There will be an advantage to look at what we have also done. And local data. So things like companies like Amazon, they are doing this kind of work in a very big scale, or YouTube. What we have done is a dialogue for specific things, mobile customers, mobile applications, different things which are content, which are related to the industry. So you may have IP here, which is not there in the big companies. So this is why I want you to ask for help and support to look at what we have done and suggest other things we can do with this. So maybe a new program, new software, or share in the computer programming, or use the statistical learning methods, develop new algorithms, new models. So some of this work was done at the CLTC campus also. The CEO there recorded me there. Mr. Robert he's the CEO of Mobitel. And I was developing a curriculum there. I have some projects also with SIT. And of course with this dialogue where I was working before. These are the areas. Telecommunication engineering is data science, it's a very wide thing. We look at statistics and apply statistics to different kinds of problems. So I have worked in telecommunication at industry, at research and dialogue, and analytics, custom analytics, also at dialogue. At the Millennium IT and London Stock Exchange is also data science and what they call quantitative finance. So these are the areas in the broad areas. At the CLTC campus, it was about we have an innovations conference there. With the COVID, I went there with the COVID. I was there for 2 years. And one of the projects was to organize a conference, recognize the innovations that come from the COVID time. Businesses change their way of working. What did they invent? They handle the problems that were there at the time. So like that, there are papers also there from SLTC and a project with SLT. I went to this ITU Telecom Development Summit many years ago in 1999. So there is a big report, a book It's about access to services. That's 20 years ago. But many of those are things that they have, of course, now been implemented. Developing the network to support the telecommunication services. All the new, more and more advanced services and the technology needed to network has to be able to support those. So these are some broad objectives for developing services at different rural areas in the cities, serving different segments, different business models, with broad objectives. So the ITU will be a place where we can just some of these things. And then there's I was given this project about a year ago to look at this a guidebook, use cases in telecommunication. It's another place where we can put these ideas. The place is called Telecom Forum. It's also an industry body, and they have a book. This is a book, big book, a data analytics guidebook. It gives a list of services or projects, innovation projects, an operator can develop using the data in the operator. So this book is a book of 100 use cases, broken up into different areas about the network itself, managing network, the customers, working with the partners, like credit card companies, using the network from the network. So this is another organization where we can put this. I have a paper on this also, looking at the different kinds of use cases where we can suggest what we have done at Dialogue. Or Dialogue can use some of these use cases in their network. So somebody has to then develop a new prototype, a project, a software, a model, and put it into their network. So this is another place where we can ask them to consider the IP. And there's a big industry. Lots of companies are in this group. They will be able to have a look at what we have done and tell us, give us some ideas. So this is another project at SLTC campus. One was about estimating the traffic profile. This is also where we can use this paper I have in design. Analysis of those use cases and developing a security application. So at SLT also, I have worked with SLT. I at the SLTC campus. So I was there for 2 years at the SLTC campus. And years at SLT are well known to me. And I did a research project with SLT to develop a network security application, detect denial of service attack. Also, we had a project with them. They funded us. There was a project to profile the telecommunication traffic. So this is another place where we can use that paper, the ideas in that paper, about looking at lower network. And then this third one is about the EM forum use cases. It's about innovating new products using the existing technology, the technology at network technology and the data at the from the network to develop new applications, manage the network, look at the traffic. So we might be able to suggest some new software or application to help them develop those use cases from our work at Dialogue and Society and MIT and the papers we have done. Many of them correspond to the different use cases, innovation projects that are listed in this TM Forum use case. TM Forum is a very big industry grouping. Thing is, how can we talk to them and so put a proposal to them. So I'm suggesting that we use one paper and then tell them we are done work like this to see whether they can consider the innovations and the IP we have, and to also talk to the standards organizations. I also went to the ASEAN Data Science Forum in Malaysia 10 years ago in 2015. I presented the work I was doing at Dialogue. So by that time, I had been there for 10 years. I had done lots of projects and papers. So I made a presentation to the ASEAN Data Science Forum. This is a company grouping from across the ASEAN group about work I was doing at Dialogue and the models and papers and what we have done for the different divisions. And these are engineering, data science, analytics, innovation projects. These are all new things. And some of the ideas are from what is out there, but specific things for Dialogue, specific use cases and projects, innovation projects, my own software, my own model, and then engineers and managers contributed to that. So we got a prototype. The software engineering model, as I tell you. We have an engineering model, something we put data into and get output. This is a mathematical formulation. Algorithm is some steps. Statistical learning is about the statistics that we can use there to get this AI or the machine learning part. We have write a computer program to do that. And from that, we can develop a commercial software also. Or we can look at the commercial software and see if we can suggest to them what we have done. It will be useful to them. And there may be some things, even if we don't commercialize it, an operator can do it for their own divisions, and they can do it on their own. Don't have to buy a software from somewhere else. They can use it, develop it internally. And they will have their own IP, but they might be able to use what we have done. So these are coming from the companies, top management initiatives to develop the company, develop the organization, develop the different GM divisions. So we want to develop the business, get better customers, but also develop the technology, get some IP, new prototypes, learn about how you might do a project like this. So we can tell the ASEAN group, or we can tell another company about what we have been doing and how much money we spent, kind of IP we have to buy, the equipment we need. It's also about the local data, data mining the local data. So in all of this, we are looking at some local data, our customers, the network traffic, the different payments, the financing, the financial part, how people pay their bills. And then we mine those, we analyze that using an engineering model and steps to do that, an algorithm, statistical learning method, like an AI model. This is inside this. This is how we will get our output. This is a way of analyzing the data. And the computer programming is how we implement this. We have to write a program to implement the algorithm. And then we can look at commercial software to see whether they have done something like this, or how we can commercialize this, what is the market for it. So this is what I want to help with. So people who are working in this area, or maybe in other areas, to see if they can use what we have done. The ISL has been helping with all this. Their committees, conferences is where I have been. I have also been in the committees, education committee, collaboration with industry, and CPD committee. We can do courses also for this. These are new things. The ISL gave me a chance to do some courses to present the kinds of data science projects I was doing at Dialogue. So there are many, many projects. This is a list of projects and the engineers who collaborated. So different areas. One is about the network, using how we might use the spare capacity in the network. This is paper is, looks at it in one way, but somebody might use this idea in a different way. That's what I'm suggesting to you. We have done this work. We have got a model, a prototype, an algorithm. We can make a software. We can produce outputs, and we can show it's working. You might be able to use this even the cell load, using the adapting the cell load admission control problem in another area. So, these are also very technical things. This is to do with telecommunication network and very specific things in the telecommunication technology, radio power technology. But there are other things, more general things, which you can use. The next one is about market share. How you might guess the market share by looking at the traffic between companies. So the traffic going from Dialogue to the other operators. Can we use that to guess how much market share Dialogue has and how much market share Mobitel and other operators have? This is also a thing that we can validate. We can prove that it's a practical thing. So you might use this idea somewhere else. About profiling customers. Number 7 is about that. That is something that can be used in another industry, in finance, in the stock market, in my profile trading. So the technology there is about developing a software to do that. Pick some variables, pick some factors, and then you can use that somewhere else. Once we have the technology to do that. But then we must use the right ideas. So here it was about looking at the payments, profiling payments for credit management. So there is a specific application developed for Dialogue, but we can use the idea, software, in another problem. Number 8 is about traffic monitoring. I won't go through all this. There's no time for this. I'll leave this with you. I can send it to you. This is an interesting one about recommending ringtones. We did that at Dialogue. One about analyzing sentiment. These are some models at stock market. Also, similar ideas about using profiling, trading in order to find out, in that particular case, manipulation in the market. So we profile trading to find manipulations or detect outliers. But you can use that for a trading application also. You can use the same kind of idea, the same technology for a different purpose, like different use. You can develop a software. This is a prototype, working model. You can develop a software in-house, maybe in a company. You can develop another software using these ideas. This is a very well-known way of doing that. I want to quickly tell what I have, why I came to ISL and asked them for this help and support. Well, this is what I was doing at Motorola. I was at Motorola for 5 years or 4 years, from 2000 to 2005, in Swindon, in England. I was a research engineer there. And we have a research group there. And our job there is to develop the 3G network and patents, research in that area. So I got 2 patents there. So I want to just tell you what we did there, because it might be helpful to suggest a way of doing this at the ISL, because we don't have that kind of big company here. How will we suggest to the telecommunication industry and standards for what we have been doing? These companies have their own research group. I was in research group. So in that we have people from the who are doing patents, patent committee, standards, people doing standards. So they are aware of what's happening in other companies in the industry and what might be possible to put into standard. So somebody has to be working with them to know that also. So we have to somehow find that out. So the big companies are doing that, and they have meetings and they are updating the board what they are planning to do several years ahead. So now they have planned for 2030 to maybe 2035. The standards are being developed 5-10 years ahead, and then the companies go and make them into products. So these ideas and patterns are useful. They will patent them, and we can't suggest them to them also from outside, because they want to have the IP on their own. They won't necessarily. We can't go to Motorola and tell them, I have this idea, unless you're working there. If you're working at Motorola, you can go and tell them, this is my idea, can you patent it? And then they can look at what is happening in the industry. Is it a useful thing, valuable to them? And then they will decide what to do. So I had 2 patents there. I'll quickly tell how we did it, just to give an idea about what we might do.
Dr. Koral, can you please increase your volume a little bit up so that will be benefit for the online audience?
Yes, right. So at Motorola, our job there as a research engineer was to research in telecommunication networks to develop new products, to improve their products, to develop IP. To do that, we have to do simulation and modeling, optimization, and it helps with the testing and deployment. So we develop an algorithm. We can test it to see how it is working. We can implement it. We can see how it's working. We might first develop a simulation model. Like I said, this simulation modeling is like an engineering model, a theoretical formulation, mathematical formulation, which we can implement in software. And then we can try and see if this is something that is going to work. And then we can suggest that if it is a new idea, if it's something very novel, we can tell our management, the patent committee, they will decide, depending on how useful it is to the company and to the industry, whether it is something that they can patent. So we can develop innovations, but the market for that and the value for them has to be decided by the company, and then a decision is taken to patent it. But these are the kinds of things we do to develop an IP, a patent in that group. So there are product requirements. So there it was about the telecommunication network, the base station, and the radio network controller, what is a part of the radio network that manages the quality of the network, how much power, when to admit users, the quality of the connection, the quality of service. So that's a very key part of the IP. You can differentiate your product. You can have cost advantage, a lot of competitive advantage. That's a part of the place where you can do some R&D. So that's a valuable area to work on. The company has different research groups working on different areas, depending on how valuable it is for them to invest in that, and where the most value can be got by doing some innovations and patents. Then they can patent it, and that will be something useful to the company in their business with the customers. So we have to work with product management also. They are the ones who will communicate what we have done. Write some briefs about what we have done. And the customers, why it is a useful thing, why it will be better than the competition. So these are kinds of things I have also been doing at Dialog as a way of testing or prototypes, doing the kinds of engineering modeling, making a simulation model, doing the optimization. Optimization is about making things efficient. In the case of telecommunication networks, it's very important because bandwidth is expensive. Network is very expensive. You want to have the least number of base stations and the most number of customers, and make it a future-proof product. So these are long-term objectives. That's why companies are working in those areas, which are the most used in the particular industry. At Motorola also, I was working on a MOU with Huawei. This is an initiative of the top management to use R&D to collaborate with Huawei company in China. Huawei company is in Sri Lanka also, but this is a part of the company that is developing the product. We are working at Motorola. We are doing the R&D, and Huawei in China is also doing the R&D. We were collaborating with them to develop some patents, some innovations, and to jointly improve the products. So we are working on a particular part of that, particular part of the product, and then we can patent it. We might be able to share the patent also. Those are kinds of things that we have decided to do, to share the R&D costs and testing and deployment, and testing a new variant. So in Sweden, where I was working, I can develop a new idea or a new simulation model prototype that has to be programmed into the actual product. That is done somewhere else. The research group, we develop a prototype. We work with our management and then look at the benefits from a simulation point of view and the novelty, the use of that. The people in the industry will know this is something that can be used in a product. So these are the kinds of things that are involved in doing that. We develop an algorithm. We look at the specifications, because these things might go in specifications, or it could be something secret we don't tell anybody. And about making innovations. And then how to manage this project. How to collaborate with Huawei. We are in China. We are in Sweden in the UK. And we want to develop a product and to share the IP. And then to have joint meetings, to tell them what we have been doing, get their feedback, ask their help and support with some other algorithms that they have given to us. So lots of things are involved in that. But it's a it was successful. We managed to invent some useful things for Huawei company and for Motorola. And that was part of the idea that they were having there. So that's for the presentation. Can I have another 10 or 15 minutes? Quickly show you a pattern and to show you what that might, what I'm telling you in the IP. I want to show you a pattern I did at Motorola. This is my manager, Louis Lopez, and this is the patent filing. So this is owned by Motorola company. I was the one who developed the solution, doing those kinds of things I told you, the engineering model, simulation, and then getting the management there to see the use of that, getting the patent committee to evaluate it, and then they will patent it. It's a useful thing for the company. And this was shared with the Huawei company also. This was part of that MOU to work with the Huawei company in China and for us to do the R&D in Sweden. And they were implementing these algorithms in their hardware in China. But they would also give us some algorithms for us to optimize. So many things were happening there. I want to show you this pattern just to tell you the kinds of things involved in developing a system. So we have a system. What this patent is about? This is about a system. And these are measurements. There is a base station and a handset. This is a picture of that. So this is the patent. This is what we patent. But what we do in as an engineer, research engineer, is to make this an engineering model. This is a picture of what it looks like, of the product, of the system. As an engineer, this is an algorithm. This is a new way of improving that system. So this is something we can simulate in a computer program, but we have to have an engineering model. So these things must make sense. We can't the measurements and what these things mean. This is about how much power to transmit from the handset to the base station to control the interference level in the base station. This is about that. The system is about that. This describes the power control system. How much power to minimize the interference in a cell. And that's a very big competitive advantage. Interference minimization, lowering the amount of interference, making the handset last longer, improving quality, reliability of the connection. Lots of advantages are there. So those things you can put in a product management production. We invented a new way of doing this. These are the actual benefits you can see. Customer can evaluate that. An operator can evaluate that, or somebody else can buy this patent or buy this part of the network. So this system, it shows a system. And the system inside this is this algorithm. This is the IP that is simulated in a computer program. This is an engineering model. And these must make sense from engineering and theoretical standpoint in telecommunication, that particular problem in telecommunication. So these things we can change how we do this. This is the flow chart. We can adapt this, do different things with this. So a computer program can test different scenarios, do lots of things with this part. And then once we can prove that this is something better than what we had before, we can trial that in the actual product and test it and see how that's actually working. So this is also trial in a network simulator. We can show certain things are actually working because we can prove it from theory and from simulation results. So we might have something we know it's going to work from simulation. The system can show that if we do this, again, number 2, that this is going to be better. We can see it's going to be better. We are sure that we can prove it. So then we can simulate it using an algorithm and get some results. We can prove we get this much more capacity, this much more quality, this much less interference. So those things may not go into the pattern, only the way we are going to do it. The new way, new flow chart, the new algorithm that we can pattern. This is what I want to show you. I want your help with what I have been doing. And this one paper I'm going to show you. Consider it maybe in this way. This is what I have been doing because Motorola, I was doing this kind of work. I was working with Huawei company from Sweden, developing algorithms in the radio part of the network, improving the algorithms by simulating and modeling them. And then the management will evaluate that. And we have a patent committee and standards representatives. They will look at the commercial viability of that. How much advantage is it to patent it? What will be the benefit to the company? How can they use the patent? So that's the example I want to just to show how you might consider this paper and what I have been doing in the other projects also. So many of the projects are in this format. What I have done in dialogue are also models that are like this, where we can simulate something, we can show it's working. Theoretically also we can prove something. The commercial value of that, how we will use that innovation, the prototype. We can work with our group companies. We can tell the standards organizations, industry companies in the industry, and get some idea from them how to use that. I made a presentation about this. It's quite a simple idea. And I developed this for the London Stock Exchange, working for the Millennium IT company. It's a very general thing. It's a very general model. It's a statistical model where we are trying to find out what is the normal number of events in a time interval. And in this case, it relates to market surveillance. Where we are trying to find out if something, an outlier has happened. So in the market, manipulating the market, there are many different kinds of ways of doing that and different ways of testing for an outlier. And then that means suspicious activity. Can we then use that to develop an alert? So one thing we have to check for in the markets is the number of trading events, how frequently they are happening. There are lots of other things we have to look in in the markets. The prices is another area. The volumes, different aspects of trading are there. But this particular model looks at a particular part of that. We can put these together. The number of events in a particular time interval, then how much change in the prices, why it has happened, is it because of the volumes, who is doing the trading, lots of information is there when people are buying and selling stocks. They record everything. The stock market wants to ensure that there is no people are not taking advantage of the market. So we are having alerts, a system of alerts, and a team to look at those. So at MIT, we were supplying software for that. I was there for an assignment to optimize the alert system. And this is a paper, a model from that. I want to say that this is something very general. I used it for to look at how we might optimize or look at the load on a queuing system of queues. And that you can use in many places. Anywhere there are people standing in line and we are having counters, we can look at that. And look at traffic interchanges. This has been used in the call centers, in the packet switching. It's been something that people have looked at for many years. This is an innovation, something new. I'm looking at this problem in a new way. And we might be able to use this idea in another problem, develop another software. Like I said, different places, we might be able to put this idea because we are using several things to make a prototype from this. It's a very simple idea. We have a certain number of events, E1, E2, up to En, and we are seeing this over a certain time interval. Actually, what we want to do is to find out how much time we want to relate the number of intervals to the number of events. So in statistics, we can do this, and we can find the total time, Z, the sum of the time intervals between the events. And then we can do statistics on that. We can find the average time. What is the uncertainty in this? And normally we might see, let's say this time interval is 10 seconds. We might see 10 events. 10 events in 10 seconds. Or we might see 5 events in 10 seconds. So there's a variation in the number of events we can see in a time interval. So that's the idea we're going to use to find out whether what we are seeing is something that is usual. And this can be done at different times. So in the markets, there are different activity levels. So they are in telecommunication also. We are looking at activity level, the network load. Those are all depending on time, different times of the day, different times of the year. And then something happens, some disaster happens, and then we might see a rise in the traffic, the internet traffic. So we can look at this in different ways, including network anomaly detection. The problem I was working on for SLT. We might use this idea in denial of service attack. They're having lots of requests coming into a web server, and then we might be able to stop it. Or we might know what is a normal amount or what is a unusual amount, outlier. And in this model, there's another important part. These are some events coming into a system, and then the system processes these events and outputs them. So statistics, we can relate that. And that is the idea we are having in this paper. But to find out that in a particular time interval of 10 seconds, we can see a huge variation in the number of events. So it depends on the kinds of what we are doing. So in the stock market, there can be many thousands of events or none at all, depending on the time of day. So in telecommunication also, it's like that. Different exchanges, different locations, different urban or rural area, different places where people have different businesses. If they are homeowners or business people, we will be able to look at telecommunication traffic also as a number of calls coming in and the number of calls ending or leaving. So we can use this model, and there are statistics we can use to say in this 10 seconds, on average, we see 10 events. So if we see what is the variation in that? So we might be able to calculate another amount, the variance in the number of events we see coming into a system. Anyway, there's a paper on this. I want to use this to tell that this is something that we can use to talk to standards or to the telecommunication companies, network companies, or other companies working in this area. So we developed a software and a prototype. We can test this. We can show it's working, but it's something that we can prove from statistics. And then how will we use it? What are the graphs we're going to plot? How will we show that it's a useful thing to implement? And what are we going to use it for? And if you get a patent, how will we get a patent and convince other companies to use this method? Or develop a software to do a particular thing, or to update a software that is already there. A statistical software might, we might suggest to them that we consider this type of model also in analyzing their data. So in network planning software, this could be something that's useful. Telecommunication network planning, while looking at the amount of traffic. It could be packets, it could be calls, or we can analyze some call arrivals and leaving in this way. And the difference will be the load on the system. We have so many calls coming in, so many calls leaving, and what is the difference will be the load on the system. And that's the way of dimensioning it, optimizing our costs. And we can relate this to queuing theory also. This picture is a prototype or a model of what was done and how we might model messages coming in and loading a system, a software system in this case, or routers in a network. So we can look at, we can apply this model to different problems. And the idea is that we look at the difference between what is coming in and what is leaving, and the variance of that is added. So because we are looking at the difference between something coming and something going, what is leaving is the service. How much time we take to serve those 10 messages. And the variance in that could be a big variation in that. So this is an important thing, an important idea consider, because those variations might be something that is usually seen also. If you look at the data in this way, we might be able to show that there is a big variation in the difference. And that is something that is normally expected. So we might optimize our system, taking that into account. The difference of what is coming in, what is given, the statistics of that, the variances, right? So we can have a big difference in the variation. And that means that we might fit a different number of events in a particular time interval. So I have some results about this. You can look at the paper. I don't want to I only want to tell you that this is about what I was saying about how you might get a patent, the kinds of engineering model, then about an algorithm, or the statistical learning, software, computer programming, and computer application software, like Excel or some software that network planners are using. Whether they would consider putting this in their software, or we can develop one in-house in our company to do look at a particular problem. So we end up with a distribution. We can look at, this is of course the arrivals, and the departures. The difference of that, we can show the variance is very big. So the idea was to find anomalies or outliers. So what is an outlier in this case? So we might see a big variation, and the distribution of that will tell us whether we are actually having a false alarm or whether we are seeing something that is normally expected because we are looking at the data in a particular way. So our data model, the way we model the data is important. Our engineering model is important. That is our IP. And that's how we prove that it's something useful. So we can use it in many places. Have the pictures here. Yeah, this is another picture we can draw. We can, when we are looking at this paper and what I am suggesting, you might consider how we represent the data. Because we are looking at the our packets or calls or customers as events, or in this case, trading events. So in the case of the markets, these are particular events. It could be somebody placing an order of a particular type. It could be a trade, different kinds of other events. It could be events outside that we are monitoring. So these are some things that happen at a particular time. And there could be several different kinds of events also. Not only trading, but we might have other events here also. So it's the question here, the model is for looking at the events and the time interval between them and saying that they are equivalent. And we can model mixes of events, and we are representing them and plotting them in this way. And this is also a way of software or people who are monitoring the network might find this to be useful. Look at the data in this way. Of course, there are many thousands of events. It will be difficult to see all of them, but we can consider this and make a software. And we can plot the data in a different way also. But the time intervals are varying. It's T1, T2, T3. They are so we can in a particular time interval, we might have a wide variation in the number of events. So what we see on average and what we see as an outlier, we can consider that. So on average, we see 10 events in 10 seconds. We see 100 in 10 seconds. Is that an outlier? Or is 1,000 events an outlier? So that's what we have to consider, the distribution of that. So we might see a very big variation in 10 seconds. Our average might be only 10. It depends on how we calculate that. And when we are looking at what time of day and how we might consider this, the window to look at this. And then, of course, this is about the arrivals. We are looking at a system that variances will add, and that will correspond to even bigger variance in what we might think is happening in the system. That's the idea of the paper. And these are equivalent to the giving models that are there. It's about modeling the load on a network as a system, what is coming in and what is leaving. We can also calculate the waiting times and service times. But the idea is to look at the load, and then in this case, how the anomaly might travel to different components. I want to quickly, running out of time. I made a presentation to SLT some years ago about what we can do at SLT. I'll send this to you also, just to give an idea about the kinds of analytics that can be done. So the companies are focusing on data, and managers are using data to improve their divisions. And the different kinds of analytics that can be done in a telco or in another company, the kinds of analysis, statistics that we can collect, and how it might be useful to the different groups, different divisions, and then help the management. So I won't look at all this. I made this presentation a couple of years to go to the SIT, one of their big data days. And I also presented this to the training school. So the training school, what are the many things that we can do. I went there in the world tour in December last year. There are lots of things we can do using the ideas of statistical learning in different parts of the business. And this kind of thing can be done. Yeah, we develop an engineering model, algorithm, software, ways of presenting the results. And those could be IP that can be used by other companies or even internally in the company for their own improve the company. And that can be developed into some internal software. Okay, I'll stop there. Thank you very much. I hope I haven't taken too much time. Mr. Vanyarach, are you there?
Yes, thank you very much, Dr. Ashoka. I mean, time to time, even though we were struggling with some audio issues, but you made a good presentation and it was very comprehensive and it contained all the information that you were requesting us to
Yes.
deliver. So,
Yeah.
and it was like the opportunity that we gave to you because of your request, and we are always promoting our membership and giving them opportunity to showcase their talents, experience, and knowledge in terms of webinars and this sort of arrangement. So that is what we did. I think if our membership is impressed, they will definitely come to you and try to get more information from you and try to work with you. So that was the platform that we created today. So I'm opening the forum for the members so that they also can contribute and give away ideas for your work. So thank you.
Thank you very much. So you can please feel free to email me with any suggestions to improve this. So this is my email to you. You can send this to the membership, Mr. Mane. Thank you very much for the opportunity. You can send me a presentation and this email. It tells you what I am trying to ask your support and why I am doing this, and for your ideas and how we might contact the industry. So thank you very much.
So I have unmuted all the online participants so that they can ask questions from you. And if you wish, we can circulate your presentation among our membership who is requesting from us. And on the other hand, this was a live recording and this will be published in our ISL YouTube channel as well. So later members can refer it for their reference.
Okay.
So I will keep the forum for a couple of minutes for anyone's queries or problems here in after. Thank you.
The bitrate related with the events and time schedule bitrate.
Thank you for the question.
Okay, thank you. If there are no any queries or questions right now, so we can wind up the session. And thank you very much, Dr. Ashoka Koral. So he voluntarily requests us to give this opportunity to present his ideas and his work he has done during his industry career. So hopefully our members got a valuable insight, even though we had some troubles time there in terms of audio at the beginning of the session. Anyway, it went well at the end of the session. So thank you very much again. On behalf of Electrical, Electronic and Telecommunication Engineering Sectional Committee, I would like to thank ISL CEO Engineer Neil Abhisekar and his team for supporting us to arrange this program. So Dr. Ashoka directly contacted Engineer Neil Abhisekar and requested this opportunity. So we gave that opportunity for our member. So thank you very much, ISL Secretary in Office and all the members who participated, and my sectional committee members who supported to arrange this forum within very short notice. So thank you very much, everyone. We'll meet in another webinar very soon with another interesting topic. So until that, thank you very much. Good night.
Thank you very much.